Hello everyone, so now we're going to calculate the distance, the shortest distance from the point 0 and 0 to the curve y equals to x squared minus 5 over 4. So what is the distance definition? It is square root of x squared plus y squared. Now when this distance actually has a minimum value, we see that it is definite that x squared plus y squared is also at its minimum value. So how about let's define the function as x squared plus y squared? Because, well, with a square root, it is much difficult to calculate. So we have this function of x and y, f of x and y is equivalent to x squared plus y squared. And we're going to calculate the minimum value of this f of x and y. And this minimum value should also meet the fact that y is equivalent to x squared minus 5 over 4. So how do we use the Lagrange multiplier method to solve this one? We first let a function L of x, y, and lambda be equivalent to, well, x squared plus y squared, this is our f of x and y, plus lambda of y minus x squared plus 5 over 4. Well, you can think of f as our constraint, and this original function, this curve, y is equivalent to x squared minus 5 over 4 be our constraint. The constraint must definitely be met. So anyways, we can see that partial L over partial x is equivalent to 2x minus 2x lambda. And partial L over partial y is 2y plus lambda. And then partial L over partial lambda would be y minus x squared plus 5 over 4. So from the first two equations, we get 2x times 1 minus lambda be equivalent to 0, and 2y plus lambda be equivalent to 0. Now let's see, if lambda equals to 1, so 1 minus lambda is 0. So we see that 2y plus 1 is equivalent to 0, so y is equivalent to negative 1/2. So y minus x squared plus 5 over 4 is equivalent to 0, so x equals to positive or negative square root of 3 divided by 2. Now, if x equals to 0, so what about lambda? We see that when x equals to 0, y minus x squared plus 5 over 4 is equivalent to 0, so y equals to, well, negative 5 over 4. Now, 2y plus lambda equals to 0, so lambda equals to 5 over 2. So now we have two sets of x and y's, and we're going to validate these two sets. So the first solution would be x is equivalent to positive or negative square root of 3 divided by 2, and y is equivalent to negative 1/2. Now, the distance can be defined as x squared plus y squared square root. So we want the minimum value of x squared plus y squared. So with x equals to positive and negative square root of 3 divided by 2, and y equals to negative 1/2, the value is 1. And when x equals to 0 and y equals to negative 5 over 4, we see that f of 0 and negative 5 over 4 is, well, 25 over 16. So the first solution is actually the correct answer because it is definitely minimum. So let's substitute our solution, which is x equivalent to positive and negative square root of 3 divided by 2, and y equals to negative 1/2, into our distance, which is square root of x squared plus y squared. And the answer is just 1.